When NASA intentionally crashed a spacecraft into an asteroid in 2022, they thought they knew exactly what would happen. They were wrong. What they discovered changed everything we thought about defending our planet from space rocks. This is how one mission revealed that asteroid defense is far more complex than anyone imagined. Meet Dimorphos, a small asteroid moon, just 160 meters across, quietly orbiting its larger companion, Didymos. In September 2022, this unremarkable space rock became the target of humanity's first planetary defense test. NASA's DART mission, the Double Asteroid Redirection Test, had a simple goal: prove we could nudge an asteroid off course by ramming it with a spacecraft. The plan was straightforward physics. A spacecraft hits an asteroid, and the asteroid changes course. But space, as we're about to see, is never that simple. On September 26, 2022, DART slammed into Dimorphos at over 6 kilometers per second. The impact was a success. The asteroid's orbit changed by 33 minutes, far exceeding expectations. But as the dust settled, literally, scientists studying images from LISACube, a tiny Italian spacecraft that witnessed the collision, discovered something extraordinary. The impact hadn't just created a cloud of dust. It had launched a swarm of boulders into space. Professor Jessica Sunshine explained the difference. When NASA's Deep Impact hit a comet in 2005, it struck a surface of fine particles, creating smooth, predictable ejecta. But DART hit a surface covered in large boulders, creating chaotic, rope-like structures in the debris. The debris didn't just push back along DART's trajectory, it moved sideways too. This sideways force could tilt the asteroid's orbit or change how it spins. The research team estimates this recoil might have shifted Dimorphos' orbital plane by up to 1 degree. Dr. Sunshine put it perfectly. You can think of it as a cosmic pool game. We might miss the pocket if we don't consider all the variables. This discovery reveals that asteroid composition and surface structure can dramatically affect how an impact deflection works. That's why Europe's Hera mission, launching in 2026, will return to examine the aftermath in detail. Every piece of momentum and its direction matters when you're trying to save a planet. DART's success wasn't just in moving an asteroid, it was in showing us that space is full of surprises. When protecting Earth, we'll need to account for every single rock. The universe got a lot more complicated, which might be exactly what we need to keep our planet safe.